Hello, welcome again. We are covering GATE Aerospace Engineering syllabus. So section 1 is Engineering Mathematics and core topic is Linear Algebra. And in this, the subtopic is your subtopic is algebraic and geometric multiplicity of eigenvalues. Okay. So first of all, algebraic multiplicity of the eigenvalue. It is the number of times that eigenvalue appears as a root of characteristic polynomial. So the characteristic polynomial is the equation of eigenvalues, characteristic equation of eigenvalues. How we will find out the characteristic equation of the eigenvalue? So this is your matrix, first row 4 2 and second row 1 2. And to find out the characteristic equation, we will subtract lambda from the diagonal element 4 minus lambda, here 2 minus lambda, and keep these same, and find out the determinant and put the determinant equal to 0, and then the equation which comes out is your characteristic polynomial that we have discussed earlier. Okay, so 4 minus lambda, 2 minus lambda, minus 2 will be 0, or the equation comes out as lambda square minus 6 lambda plus 6 is equal to 0. From this we get two roots, lambda 1 is equal to 3 plus root 3 and lambda 2 is equal to 3 minus root 3. So as both are different, so it means both are appearing one time. So if we take this eigenvalue, then we can say its algebraic multiplicity is 1 because it is appearing only one time. If we take this eigenvalue, then we also can say its algebraic multiplicity is 1 because it is occurring only one time. So algebraic multiplicity of this eigenvalue is 1 and the multiplicity of this eigenvalue is 1. So algebraic multiplicity is number of times that eigenvalue is appearing. Okay. So that is the definition. Algebraic multiplicity of eigenvalue is the number of times it appears. Okay. So now if we take another example, for this is a matrix 1 0 2 1, and to find out its characteristic polynomial or its polynomial equation, 1 minus we will subtract lambda from diagonal elements. Okay, so then solve it for determinant. So it will be 1 minus lambda square equals 0, or we can say 1 minus lambda is equal 0 or 1 minus lambda is equal 0. So it will have two roots, both are equal. So that is that are 1. So it means its algebraic multiplicity is of 1 is 2 because 1 is occurring 2 times. Okay, so the this eigenvalue has algebraic multiplicity equal to 2. Okay, so now we can understand the algebraic multiplicity. Number of times a particular eigenvalue is appearing, that is the algebraic multiplicity of the eigenvalue. So next is your geometric multiplicity. Geometric multiplicity. So geometric multiplicity of an eigenvalue is the I am reading out definition and then I will explain. Geometric multiplicity of an eigenvalue is the dimension of linear space of its associated eigenvectors, or we can say that linear space of the associated eigenvector is called eigenspace. Okay, or we can say geometric multiplicity of a particular eigenvalue is nullity of a minus lambda, that is matrix. Okay, and nullity of a minus lambda is n minus a minus lambda is. So I will so now this example will explain all the things. Suppose we have matrix A 2 0 1 1. Okay, and characteristic polynomial is 2 minus lambda minus 0 1 minus lambda is equal to 0, or 2 minus lambda 1 minus lambda is equal to 0, or roots are 2 and 1. Okay, if we take lambda is equal to 2 and find out a minus lambda I. Okay, a minus lambda I. So lambda is your 2, and so this will be 0 and this will be your minus 1. So we can see that this row is becoming 0 0 0. So it means nullity of this matrix is 1 because one row is 0 and one other row is not 0. So nullity of this a minus lambda is your 1. Or in other way we can say that rank of this matrix is 1 and order of this matrix is 2. So duality of this matrix will be 2 minus 1 is equal to 1, or geometric multiplicity is your 1. Okay. So now take another example. 1 0 minus 1 1. Add find the characteristic equation. 1 minus lambda 0 minus 1 1 minus lambda. So it will be 1 minus lambda square is equal to 0, and lambda 1 lambda 2 will be equal to 1. And so it means its geometric is algebraic multiplicity is your 2. Okay. So now if we take lambda, because both are same, so if we take lambda is equal to 1 and find out a minus lambda I, then it will be 0, and this will be 0, this will be 0, this will be minus 1. Okay. So it will be minus 1. So its rank will be your 1, and geometric multiplicity will be your 1. Okay. So because the order is 2 and rank is 1, so geometric multiplicity is 1. If we take another example, so this is 2 2 2 0 0 2, and finding out the eigenvalue. So 2 minus lambda 0 0. Okay. So lambda will be a 2 2, and if we find out the rank of this a minus lambda I, putting lambda is equal to 2, so here it will be 2 minus lambda 0 0 0 0, so rank will be 0, and geometric multiplicity will be 2 minus 0, that is 2, order minus rank. So this is all about geometric multiplicity. So next topic is defective eigenvalue. So defective eigenvalue is defined as, so when the geometric multiplicity, here we have found out geometric multiplicity, that is 2, and algebraic multiplicity is also 2, because lambda is occurring 2 times. So when the geometric multiplicity of a repeated eigenvalue is strictly less than its algebraic multiplicity. So here both are equal, algebraic multiplicity is 2 and geometric multiplicity is 2, so that is not defective. If geometric multiplicity is less than algebraic multiplicity, okay, then the eigenvalue is said to be defective. And for the defective eigenvalue, eigenvectors are linearly dependent. Okay. So for defective eigenvalue, the eigenvectors are linearly dependent. They depend upon each other, because then there will be one vector equation. Okay. And so they will be dependent upon each other. Geometric multiplicity is less than algebraic multiplicity, then the eigenvectors are linearly dependent. For distinct eigenvalue, because here this is about when the repeated eigenvalues are there. Okay. So when the distinct eigenvalues are there, then they are not dependent upon each other, so they are linearly independent. So in this case, okay, when the geometric multiplicity when the algebraic multiplicity is more than 1, or we can have multiple same eigenvalues, and geometric multiplicity is equal to algebraic multiplicity, then the vectors are linearly independent. So in this case, when geometric multiplicity is less than algebraic multiplicity, then the vectors are linearly dependent. Otherwise, in both the cases, when there are different eigenvalues and there are multiple eigenvalues, multiple same eigenvalues, okay, then the vectors are linearly independent. Okay. So generally, this case occurs, geometric multiplicity is less than algebraic multiplicity, and geometric multiplicity cannot be more than algebraic multiplicity. Either it will be less than, or it will be equal to the algebraic multiplicity.